Today we will be looking at the average rate of change between 2 points on a function. We will be focusing for our objectives here simply on average rate of change, and students will be able to calculate the average rate of change between 2 points on a function. We'll talk about the difference quotient in a separate video to follow. So if we talk about average rate of change, we're talking about, once again, how the independent variable and the dependent variable interact with each other. If I have some function f, so the black curved line, what I have is going to be the graph of some function f. So we represent that as y equals f of x, the graph of f of x. And I have 2 points on that function, one point p, and we'll give it coordinates x sub 1 comma y sub 1, and a point q, and we will give it x coordinate x sub 2 and a y coordinate y sub 2. And we want to find the average rate of change between those 2 points. And if I connect those points with a straight line, that is called a secant line. A secant meaning intersecting at 2 points. And the average rate of change is going to be the slope of that secant line. So that's something we write down here. Average rate of change really means that we're finding the slope of the secant line. So how do we go ahead finding the slope of this secant line? Well, we can go back and use some of our very old Algebra 1 type formulas. And I could say that's going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. However, since we are working in precalculus and we're going to be working with these as functions, and we might not even have the graph in front of us, we're going to make a replacement. We are going to replace y sub 2 with the notation f of x sub 2. And those are equivalent representations of the same value. Y sub 2, meaning some output, some y coordinate, and f of x sub 2, what is the result when we put x sub 2 into the function. Similarly, I can replace my y sub 1. I'm actually going to erase this whole thing to make it look a little bit better there. Get all my pieces. That would be f of x sub 2 minus f of x sub 1. So this is generally the formula that we use to find the average rate of change between 2 points. And all it is, it's a little bit more of a sophisticated version of the slope formula applied to this secant line. So our formula, f of x sub 2 minus f of x sub 1, meaning the result of putting x sub 2 into the function minus the result of putting x sub 1 into the function, divided by x sub 2 minus x sub 1. Word of warning, be careful, since these are all defined with division and subtraction, order does matter. You cannot switch the order of these pieces. You got your 2's and your 1's to be first and last as they are. All right? So here's a quick example that we're going to work our way through. Given f of x equals x to the 4th, find the average rate of change from x equals negative 1 to x equals 0. So our formula for average rate of change, just rewriting it to practice it, f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. So f of x sub 2, my second x is 0, so that's f of 0, minus f of x sub 1, my first x was negative 1, over x sub 2, my second x is 0, minus x sub 1 minus negative 1. So I've made my substitutions. It's going back to function evaluation, being able to put something into a function and simplify it. F of 0, well, our function is f of x equals x to the 4th. So f of 0 will be 0 to the 4th minus f of negative 1, which will be negative 1 to the fourth, over, and the 0 minus negative 1, I'm going to rewrite as a 0 plus 1 to make it easier to work with. 0 to the fourth is 0, minus negative 1 to the fourth, being negative 1 times negative 1 times negative 1 times negative 1 is positive 1, over 0 plus 1, which is 1, giving us negative 1 over 1, which is negative 1. So that's our average rate of change for the function between negative 1 and 0. It's not true all the time, but just for that part. And what this means is from x equals negative 1 to x equals 0, the average rate of change is negative 1. Meaning, if I was to take my curve and connect the points with a straight line, the slope of the secant line that connects those 2 points is negative 1. That's what that means. And it gives us the average rate of change. So that's one example. We'll go through another example as well. Example 2. Given f of x equals x squared minus 3, find the average rate of change from x equals negative 1 to x equals 2. And I'm going to do it just like we did before. I'm going to write the formula to make sure I have it correct. If I have to go look at my notes, I'll go look at my notes. F of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1 equals, now here my second x is 2, so that's going to be f of 2 minus f of negative 1 over 2 minus negative 1. So really what I'm doing is I'm saying, what's the slope if I take my point with the x-coordinate of negative 1, and I take the point on the curve that has an x-coordinate of 2, and I connect them with a straight line, what's the slope of that line going to be? Well, I can figure it out without actually having to make the graph. F of 2 is going to be 2 squared minus 3, minus f of negative 1 is going to be negative 1 squared minus 3, all over 2 plus 1. So here we've got that function evaluation idea again. I've got to be able to substitute in properly. If you're struggling with how did I go from here to here and here to here, I suggest you do a search and try to find a video on what's called function evaluation or evaluating functions to help you out there. Anyways, 2 squared is 4, 4 minus 3 is 1, minus 1 squared is 1, negative 1 squared is 1, minus 3 is negative 2, 2 plus 1 is 3, giving us 1 minus negative 2, that would be 3, over 3 equals 1. So if I write a sentence or two here to say what does that 1 really mean, it means that the average rate of change for the function from negative 1 to 2 is 1. Okay, great, Mr. Flamino. What does that mean? Well, that means that if I took the points on the curve and connected them, that the slope of that line that connects them, the slope of that secant line is positive 1. If I had my curve for the function f, I took the point at x equals negative 1, I take the point at x equals 2, I connect them with a straight line, that straight line is called the secant line. That secant line is going to have a slope of 1. And this gets into rates of change, and we start talking about what we might do with that in physics or calculus or so on and so forth. Here's some practice. Why don't you pause the video, take a read on the problem, try it yourself. Once you get to the end, unpause the video, come back, and get the solution. Okay, we're back. Hopefully we tried it ourselves. So here's what the solution looks like. The formula, f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. X sub 2 is 3. X sub 1 is 1. We have our function evaluation. That's going to be 9 minus 3 squared minus 9 minus 1 squared over 2. The numerator turns into 9 minus 9, which is 0, minus 9 minus 1 is going to be 8 over 2. So that gives us negative 4. So the average rate of change for this function f, which is the function 9 minus x squared, is negative 4. Once again, what does that mean graphically? It means the slope of the secant line that connects the points at x equals 1 and x equals 3 is negative 4. So the line would be going down. So I hopefully you found this helpful. Just a few examples. We'll come back into class. We'll work on a little more and take it from there. Thank you very much.